Problem 523. Passenger of mass 50 kgs in a car rounding a level curve of radius 100 meters. That's sketched off to the side here in top view. Here's the center of curvature of the turn. The turn is going around on this imaginary circle with radius r. Velocity, as I sketched it here, is upwards, and acceleration is pointed directly towards O. Rounding a curve at of radius 100 meters at a speed of 20 meters per second. Assuming that friction is the only horizontal force acting on the passenger, find the frictional force. Okay, so here's a side view with an FBD. There's a normal force from the ground, N, and a downward weight force, and then a frictional force acting to supply the centripetal acceleration required. And I'm going to take my x-axis in that direction, same direction as the S of F. So Newton number 2 tells me that the at this particular instant of time, the mass times the x-acceleration is equal to the force. But we know that the x-acceleration is equal to the centripetal acceleration, which is v squared over r. Therefore, the frictional force is equal to the mass times the centripetal acceleration, which is mv squared over r. Putting the numbers in, 50 kilograms times 20 meters per second squared over 100 meters, which comes out to 200 newtons. And this, of course, assumes no sliding, or in other words, that mu sub s is large enough to supply the friction. For part B, we're going to assume a specific mu sub s, 0.3. I can assume that n is equal to mg. I can do that from Newton number 2 in the vertical direction. And then the frictional force is mu sub s times n, which is, since n is equal to mg, mu sub s times mg. Working the numbers here, 0.3 times 50 times 9.8, it's about 150 newtons, which isn't up to the task of the 500 newtons required for the centripetal acceleration to occur. And so it's not large enough. The passenger will therefore slide to larger r. The passenger will slide out this way until there's an additional force that gives you the passenger the required total inward force, and that might perhaps be by the horizontal N from the car door. And so I've sketched that out here with a new FBD. I'm calling this N the ground M, and this mg as before. This little vector is the S sub F, and this is the N from the door. When that happens, then the total inward is equal to the centripetal acceleration, we're back to the non-sliding passenger scenario.